PM4-100. Switching power supply mode. Behavior of voltage and current on different resistive load. Introduction. The PM4 can be used either in 3-stage battery charger mode or as a fixed power supply approximately 13 to 16.5 volts. Let's see the behavior at the output of the unit for different current value. For example, from 0 to 100 amps on a prototype electronic load. The purpose of this video: take a look on the PM4-100 unit in fixed mode and evaluate the stability of the voltage and current with different resistive load. The approach: the use of a water-cooled electronic load will be used. During the test, the PM4 unit will be adjusted in fixed mode with an output voltage of approximately 13.6 volts. Equipment used during the test: use of a shunt to monitor total current, prototype electronic load with water cooling system. The electronic load uses 4 N-channel MOSFETs in linear mode. The water cooling system: a quick overview. There is a pump for water circulation. There is a 4 heat exchanger unit for each MOSFET. There is a radiator unit and distilled water reservoir about 500 milliliter. Measuring devices: there is an oscilloscope, Mixig T01104, a data logger, Yuki LR8431, a current probe, Prove CM-05, and different power supplies, for example, B-key for the water pump, X-Tech for the breadboard, and another BK for the voltage control on each gate of MOSFET. Handling tests on the workbench. The tests will be made by variation of current on the electronic load, for example, in steps of 10, 25, 50, 75, 85, up to 100 amps. Let's take a look. There are 2 lines on the oscilloscope. The yellow line represents the voltage at the output of the PM4 unit, adjusted to around 13.6 volts. The blue line represents the output current, which can vary from 0 to 100 amps. Let's start with a current of 10 amps. On the oscilloscope, there is a little noise on the output voltage and the output current. It's very low. We will increase the current to 25 amps. The output voltage fluctuation increase a little more and the output current looks with a little noise. We will increase the current to 50 amps. The fluctuation of the output voltage increase a little more and the fluctuation of the output current also increase. We will increase the current to 75 amps. The fluctuation in the output voltage increase a little more and the fluctuation in the output current seems to be stable. We will increase the current to 85 amps. The fluctuation in the output voltage increase a little more and the fluctuation in the output current also increase. We will increase the current to 95 amps. The fluctuation in the output voltage increase a little more again and the fluctuation in the output current also increase. We will try to increase the current to 100 amps. The output voltage drops to around 3 volts and the output current remains high around 95 amps with the presence of fluctuation. We will decrease the current to 85 amps. The output voltage reappears around 13 volts and the output current remains high at approximately 85 amps with the presence of fluctuation. We will decrease the current to 0 amp. The job is done. The conclusion. In conclusion, the behavior at the output of the unit PM4-100 for different current values has been achieved. For different current variations, the blue line in steps of 10, 25, 50, 75, 85, up to 100 amps indicates an effect on the output voltage, the yellow line. On the output voltage, there is a fluctuation rate of about 2 volts. For example, in this video, for an output adjustment of 13.6 volts, there is a variation of approximately 12.4 volts minimum and approximately 14.4 volts maximum for a current of up to 100 amps. The overcurrent protection seems to operate from an observed current over around 95 amps. In this case, the output voltage drops to about 3 volts and the output current remains high around 95 amps. The PM4-100 unit in fixed mode seems to indicate an interesting advantage for the applications of some 12 volts equipment. It would be interesting to observe the behavior of the PM4 unit on some equipment like pumps, camping fridge, LED lighting, RV, and etc. Thank you for watching.